Carbon is a nonmetal of group 14 which consists of 6 electrons and 6 protons. On Earth, most carbon is stored in rocks and sediments while the rest is located in ocean, atmosphere and in living organisms. The element carbon occurs in different forms in nature with wide variety of physical properties. Carbon exists in two forms, crystalline and amorphous. In crystalline solids, the constituent particles are arranged in a definite order, but in amorphous solid, the constituent particles have no definite order of arrangement. Coal, coke and charcoal are amorphous form of carbon, whereas graphite, diamond and fullerene are crystalline form of carbon. Both these forms are called allotropes of carbon. So let's now understand what is allotropy and what are the different allotropes of carbon. Allotropes are forms of same element which exhibit different physical properties but share similar chemical composition and comparable properties. These different forms of the same element are called as allotropes or allotropic structures. Carbon is one element which demonstrates allotropy. A few examples of allotropes of carbon are graphite, graphene, carbon nanotubes, C60, C70, C540, amorphous carbon, lonsdaleite and diamond. Similar to carbon, a few other elements like sulfur, phosphorus and oxygen also exhibits allotropy. For the time being, let us learn the different allotropic forms of carbon. The three main crystalline allotropic forms of carbon are diamond, graphite and fullerene. Let's learn in detail about each of these allotropes. Diamond is a giant crystal molecule and it is the hardest crystalline form of carbon. In diamond, each carbon atom is linked to 4 other carbon atoms forming a rigid 3-dimensional structure. As all the valence electrons are involved in the bond formation, there are no free electrons available in the structure. This makes diamond non-conductor of electricity. Graphite. Graphite is a naturally occurring form of crystalline carbon commonly known as black lead. It is a grayish, black, opaque substance. It is lighter than diamond and it is smooth and slippery to touch. Graphite is a good conductor of heat and electricity. Now let's see how the carbon atoms are arranged in graphite. In graphite, each carbon atom is linked to 3 other carbon atoms through strong covalent bonds and form hexagonal rings. These hexagonal rings are arranged in layers one above the other. The various layers of carbon atom are held together by the weak van der Waals attractive force. So, the layers are not fixed and they can move or slide over another, resulting in the smooth, slippery nature of graphite. There are free electrons present in the structure of graphite, which make it a good conductor of electricity. Let's have a comparison between diamond and graphite. In diamond, every carbon atom is bonded to 4 neighboring atoms through covalent bonds. In graphite, every carbon atom is bonded to 3 other carbon atoms by covalent bond. Diamond exists in tetragonal 3-dimensional structure, whereas graphite exists in hexagonal layered structure. Due to the absence of free electron in diamond, it is a poor conductor of electricity, whereas graphite is a good conductor of electricity due to the presence of free electrons. Pure diamond is the hardest natural substance, whereas graphite is soft, it is black, brittle and slippery in nature. Let's now examine another carbon allotrope, fullerene. A fullerene is a molecule which consists of carbon atoms connected by single or double bond so as to form a closed or partially closed mesh. So chemically, fullerenes are formed by the combination of large number of carbon atoms. The structures of some of the fullerenes are shown here. C24, C28, C32, C60, C50 and C70. The numbers 24, 28, 32, etc. indicate the number of carbon atoms present in that structure. This is C540, which is a fullerene that consists of 540 carbon atoms, and we can say that it is a very giant fullerene. The first fullerene to be identified was C60. It consists of 60 carbon atoms. C60 resembles a football and we can say that it is a spherical fullerene. The other name of C60 is Buckminster Fullerene. It is named as Buckminster Fullerene to pay homage to the American architect Buckminster Fuller for his geodesic dome, which looked oddly similar to the molecule in its structure. C60 consists of 12 pentagons and 20 hexagons. It's neither very soft nor too hard. C60 is also called as buckyball. A few more examples of fullerenes are C70, which is shaped like a rugby ball. Fullerenes that have less than 60 carbon atoms are called as bucky babies. Fullerenes that have a coating of hydrogen atoms are called as fuzzy balls. Let us now recall once again the contents discussed in this video. There are two main forms of carbon known as crystalline and amorphous form, and both these forms are known as allotropes of carbon. And the phenomenon where an element exists in different physical structures is known as allotrophy. So I hope that you are now clear with the three allotropic forms of carbon and its various description. Thank you for watching this video. If you like this video, do hit the like button and share the video among your friends and family. Do give your love and support by subscribing the channel, and don't forget to hit the bell icon to get the notification instantly when the videos are uploaded.